All right, let's take a look at question 15. For question 15, we're to sketch the graph of the function that meets the given conditions. Um, limit as x approaches infinity of the function is -2. Limit as x approaches -2 from the left of the function is -3. Limit as x approaches 1 of the function is -infinity. Limit as x approaches -2 from the right of the function is 3. And limit as x approaches -infinity of the function is 0. All right, so to get started, we'll just go ahead and set up our coordinate system and then label it afterwards. So let's draw our y coordinate and our x coordinate. Now we have as horizontal asymptotes because as x approaches -infinity, the function tends towards 0. So we're going to have a horizontal asymptote at the left end because that's where -infinity is located. And then at the right end, we have another horizontal asymptote at -2. So down here, -2, we have a horizontal asymptote. And then at 1, we have limit of x approaching 1. So let's draw a horizontal line right there. That's the value that x is approaching. And then also at -2. Okay, we have another line right here. Okay, so let's go ahead and label what we have. From this direction is -2 from the left. From this direction is -2 from the right. From this direction is 1 from the left. And then on this side is 1 from the right. All right. When we're going to infinity, the function tends towards -2. So it's either on the top or on the bottom. What I'm going to do is I'm going to use the right side limit at x equals 1 to figure out what is going to happen. As x approaches 1, there's no direction here, so this is a double-sided limit. As x approaches 1 from both sides, the function tends towards -infinity. For the x's, this is infinity, and this is -infinity. For the y's, or for the function, upstairs here is infinity, downstairs here is -infinity. So since the function tends towards -infinity as x approaches 1 from both sides, so I'm going to put um, a portion of the graph here heading downwards towards -infinity, and then another portion here heading towards -infinity. We have a vertical asymptote somewhere here. Okay, so we have a vertical asymptote here and also there. Okay, now let's see. Now we can see that in this piece right here, as x tends towards infinity, we can put a portion of the graph here because we have a horizontal asymptote, and then we can somewhat connect these two. All right. Now we're done with x approaching infinity. That's good. X approaching 1 from both sides. This graph right here and this graph. That's good. Now, as x approaches -2 from the left, you're approaching -3. So 1, 2, 3. So it's kind of like this from the left. Let's make it something like this, approaching -3 from the left. And then as you're approaching -2 from the right, the function approaches 3. 1, 2, 3. So we're getting arbitrarily close. That's why I have an open circle, okay? So I'm going to do it downwards. You know why? Because we have something here. And then as x approaches -infinity, the function approaches 0. So I can put something underneath the horizontal asymptote since I already have a function here, okay? So what we're just going to simply do is connect the dots in whichever way we want, but we want to ensure that the graph is still a function that passes the vertical line test, okay? So I just draw it this way, like that. It goes on forever. That's one portion. And then this one, let's see how we can connect it. Just connect it like that. Okay, have a horizontal asymptote there. And then this one, just connect it. Uh-oh, let's do that again. So we have a horizontal asymptote, and then just try and connect these two lines. It's kind of hard using this device, so we'll just go straight, and then just connect it like that. All right, so there goes a possible solution to your graph. Let me make it more asymptotic here. Let's try this again. So goes out, and then tends towards your horizontal asymptote, and then starts to just flatten out. Okay, like this. Bam. So there goes a possible graph for this situation. So we have -2 from the left, check, -2 from the right, check, x approaching negative infinity, check. All the components have been accounted for, and then we're good. So thanks so much for taking the time to watch this presentation. This was a really fast review for those of you who have already mastered limits. If you want a much slower step-by-step explanation, you can go to matgoserve.com under AP Calculus, and you can look at our mixed review videos. They'll be much more thorough in explaining the processes for generating the results. Feel free to subscribe to our channel for updates to other great tutorials such as this. And please post a comment to let us know what you think about this tutorial and ways that we can create more great tutorials for you to master mathematics. Thanks again for watching, and have a wonderful day.